This video will describe chapter 4.3, writing equations in point-slope form. So first thing we want to do is talk about the point-slope equation, or point-slope form. And so this is the equation on top. Y minus y1 equals m, and then in parentheses, x minus x1. And so I want to talk about what each of these terms means. So this x, the blue x and the blue y, are essentially any point along this line. So remember we talked about a line being made up of an infinite number of points? These are the infinite number of points. So though this x and this y will always be there. Similar to the y, x and y in y equals mx plus b. In the equation you always see the y and the x. You should always see these two. Now, x1 and y1 are the point that you are given. So there's a given point, which is why you're probably using this form. And so this is the x value and this is the y value. Now I want you to keep in mind that, like, if this were a 3 and this were a 2, then this would be x minus 3 and this would be y minus 2. Whereas, and we're going to practice one of these, if the point is negative 2 and positive 4, this would be y minus 4, but then over here it would be x minus negative 2, so this would become positive, this would be x plus 2. So basically what's confusing for a lot of people in this form is that when these two are subtraction, that means the x1 and the y1 are both positive numbers. But if they're addition, it means they're negative, right? And obviously one can be negative and one can be positive. And then this m is the same as the m from y equals mx plus b, and so this is just your slope, right? And you obviously, hopefully at this point, know now the formula to find slope, y2 minus y1 over x2 minus x1. That's what that is. All right, so I'm going to leave this off to the side because we're probably going to come back and take a look at it. So we're going to start by writing an equation in point-slope form for the line that passes through this point and has a slope of 1/4. So what I'm going to do is I'm going to call this x1 and I'm going to call this y1. All right, so looking back at my formula, which is y minus y1, so this is going to be, and I'm going to write out all of the negatives just so that we're in this together. So this is y minus y1 equals m times x minus x1. All right, I'm going to come back to this slide in just one second. Using this formula, y minus y1 equals m times x minus x1. Y minus y1 equals m, right, which I'm getting from here, m times x minus x1. Okay, now the thing is I want to make sure I simplify this, and so these two can obviously become a positive, so this is going to actually become y plus 2 equals 1/4 times x minus 3. Now, many people at this point are very tempted to distribute. You do not want to distribute, you should leave it, so this is my answer. Right? And often you don't even have to take the second step because if these work out okay, you can just leave the answer. So don't distribute. I mean, it's great that a lot of you are now like conditioned to distribute, but in this particular point, slope form, I want to leave it inside of the parentheses. So that's the whole point of the form. So the idea with this form, right, the advantage why somebody might want to use this form is I now know a point, so pretend I didn't know this. Just looking at this equation of the line, I can now tell you the slope, because I know that m is the slope, right? So I know that would be the slope. And then I can also tell you a point on this line, because I know that this is x1, and it's x minus x1, so that means that x is positive 3, and then y minus y1, and since this is not a negative sign, it's a positive sign, I know this must mean that this negative sign must have flipped the subtraction sign to make it positive. So I would be able to, just looking at this part, tell you all of that. Right? And that's the advantage to using this form. If you distribute, I can no longer do that. Right? If you distribute, then it no longer becomes useful. We're actually going to practice distributing it in just a moment, but that's for a different purpose. Okay, so this red circle is my final answer for something like this, as long as it says that they want it in point-slope form. Now, let's talk quickly. It's a quick reminder about standard form. We talked about this a little while ago. Standard form is ax plus by equals c. This is also an equation of a line. The two main rules with standard form are that a, b, and c must be integers, so that's positive or negative whole numbers. So for example, 1, 2, 3, 4, or 0, or -1, 2, -2, -3, -4. They can't be fractions. Okay, and then a must be positive. This number cannot be negative. This can be negative, this can be negative, but this number cannot be negative. Okay, so we're going no fractions, and a is positive. So what we're going to do is take this equation, which is currently in point-slope form, right? Y minus y1 equals m times x minus x1, and we're going to put it into standard form, which means now is one of those times when we are actually going to have to distribute. Okay, so this becomes y minus 1 equals negative 2/3 x plus, right, because now it's negative times negative, plus 10/3. So there are a couple things I can do, but I'm not going to necessarily get rid of the fraction just yet. If you wanted to, you could multiply everything by 3, but we're going to deal with that in a moment. So first what I'm going to do is I'm going to add 1, because I want to get the y by itself, and then I'm going to bring the x over. So this becomes y equals, and this is negative 2/3 x. When I add 1, remember 1 is the same as 3/3, so this is going to become plus 13/3, right? Because I had 10/3, I'm adding 1 over here. Because I add 1 to this side, I got to add 1 to this side, and then this is the same as 3/3. So remember, you got to have a common denominator, and then we add the numerators. So this is 13/3. Now, hopefully, many of you recognize this form of an equation. Right? So the next problem that we're going to do is actually going to be taking something from point-slope form and transforming it into y equals mx plus b, slope-intercept. But I now know the slope of the line, and I also can tell you what the y-intercept of the line is, but that's not what they want. They want this to be in standard form, so there's one extra, or I guess 2 extra steps in this particular problem. I now need to move this negative 2/3 x, I got to bring it over to this side, so I'm going to add 2/3 x to both sides. Remember that the x and the y can't combine, so this is now 2/3 x plus y equals 13/3. Okay, but remember now I'm violating one of the rules. Let's bring that slide back for a sec. So at this point the a is positive, right? It's positive 2/3, but my problem right now is that I have a fraction. So had it been negative, I would have to multiply everything by -1 and I could bring it back, but now I got to get rid of this fraction. So in order to get rid of this fraction, what I'm going to do is I'm going to multiply everything by 3. So it's going to be this whole thing by 3 and then this by 3. Now when I multiply 3, remember it's got to go to both of these. 3 over 1 times 2/3, right? Some people see it as you kind of cancel those out and you're left with 2. Some people see it as 6 over 3. But either way, this 3 times 2/3 should give me 2x. Plus, don't forget I got to multiply the 3 times the y also. 3 times y is 3y equals, and then these 3's will cancel out, and I'm left with 13. Or some people see that, right? If you see it as 3 over 1, it becomes 39/3, and 39/3 simplifies to 13. So my final answer in standard form is ax plus by equals c. Now keep in mind b could be negative, so let's assume for a second that this was negative, then it would just be 2x minus 3y, and that's okay. It's as long as this number is not negative. Alright, and then one last problem, and now we're going to take, again, a number that, equation of a line that is in point-slope form, so I now know a point and the slope. I know the slope is 3/2, right? I know a point because this became positive. My point that I know is -1 and -3, right? x1, y1, but because it's supposed to be x minus x1 and this is x plus x1, this negative sign must have flipped that to addition, and same thing over here, right? I know that my slope is 3/2. That's the slope. But that's not what they're asking me. So what they're asking me is to make this into y equals mx plus b. So what I'm going to do is I'm going to take this, I'm going to distribute it, and so I go y plus 3 equals 3/2 x plus 3/2. Now again, I could multiply everything by 2, but at this point there's really no point since I'm not afraid of fractions, right? So what I'm going to do is I'm going to subtract, I'm going to isolate the y, right, because I want it to be y equals mx plus b, so I want to get y by itself. I'm going to subtract 3, remember 3 I'm subtracting from there. So this cancels out, and I'm left with y equals 3 halves x, and then 3 halves minus 3, right, or 1 1/2 minus 3 gives me negative 1 1/2, or negative 3 halves. Right? The other way some people might see this is 3 halves, and this is the same as 6 halves. So it would be 3 halves minus 6 halves gives me negative 3 halves. So this is my equation of the line in slope-intercept. So now, what's great about this is through these steps, I've now figured out the slope, right? It's 3 halves. I can either see the slope of 3 over 2 here, and then obviously since it's the same line, the slope should not change. So the slope is still 3 over 2. And then I now know a point on that line, which is negative 1, negative 3, but I also now know the y-intercept, right? That's my y-intercept. So if I were to graph this, I could go to negative 3 halves, negative 1 1/2, and I could put my dot on the graph, and then if I wanted to, I could rise and run, rise 3, run 2, or I could take this point, negative 1, negative 3, put that on the graph, and then connect the 2 points. So there's a lot of ways I can get points when they give me something like this, and then I change it into this form. All right, so that's all I got for you in this section. We're going to be doing a lot of changing back and forth between the forms. So it's really important to know slope-intercept, y equals mx plus b, point slope, y minus y1 equals m times the quantity of x minus x1, and then standard form, ax plus by equals c. All three are equations for a line. So we're going to practice that in class. Don't forget to do the problems on the bottom of this page. Thanks for watching the video, and I'll see you in class.